we noted last time that electrons are in atoms are described by the magnetic spin quantum number m sub s, and the magnetic spin quantum number m sub s can only have two values. What are they? She says positive 1/2 and negative 1/2. She's right. So the way things work out, therefore, you can have only two electrons at a maximum in a given orbital. Okay, that's the most you can have. So the possibilities are 0 electrons, 1 electron, or 2, but not more than 2. So with that in mind, let's look at these questions. How many electrons in an atom can have each of these quantum number designations? First of all, n is equal to 4. That, of course, is the fourth shell. And in case you didn't notice it, there's a shortcut to answering this question. You can either go through and do the subshells and figure out how many orbitals there are in each subshell, add up the total number of orbitals, and multiply by 2, and you'll get the total number of electrons. Or you can remember that n squared equals the number of orbitals in a shell. And therefore n squared, 2n squared, is the number of electrons. So in this case, when n is equal to 4, there are 16 orbitals times 2 electrons per orbital. Maximum gives 32 electrons as the max that you can have in the fourth shell. Does anybody have a question on that one? So that's a nice shortcut to remember. If you be careful when you answer questions, whether it says what's the maximum number of orbitals or electrons, the answer is different. Okay, 2 electrons is the maximum a given orbital can hold. If there are no questions on that one, let's look at B. We have n is equal to 4 and L is equal to 2. If n is equal to 4, L can take values of 0, 1, 2, and 3. In this case, n is equal to 2 specifies a particular subshell. Which subshell is it? 4, say it again? D, the 4D subshell. And how many orbitals are there in the 4D subshell? 5. There are 5 orbitals in every D subshell. So 5 orbitals times 2 electrons times this subshell has, well, 5 orbitals times 2 subshell is 10 electrons that it could have. Questions on that one? Let's look at the third one then. N is equal to 3, L is equal to 1, M sub L is equal to 0. Is that an allowed combination? The answer is yes, it is. If n is equal to 3, L can be 0, 1, or 2. If L is equal to 1, M sub L can be negative 1, 0, positive 1. Okay, so that's a legit combination, and the 3 subshells specify an orbital. Okay, and it's the 3p orbital, one of the 3p orbitals. It could be the 3px, the 3py, or the 3pz, and it really doesn't matter because one orbital holds 2 electrons at a max. So the total number of electrons that could be housed in that particular substructure of the hydrogen atom is 2. So the answers are 32, 10, and 2.